today, the agenda will be, I will first of all talk about our Microsoft Connect toolkit. So I'll give you a brief introduction to what it is and how you can leverage this deep learning framework to build your own deep learning projects. And also we have some very comprehensive templates and source code available on GitHub that enables you to play around with many different other open source framework. And also in the second part of my presentation will be on introducing some of our content service APIs. So I will give you a latest update on some of the new APIs available from Microsoft. So basically they are all off the shelf and very easy to consume. No matter what platforms you're on or what language you are playing around with, you can just call this API to do all the fancy stuff and bring intelligence to your applications. So now, and also before I end my presentation, I will also give you a small, so basically show you a small demo, basically showing you how you can actually create a data science virtual machine on Azure. So our data science virtual machine now equipped with all the open source and third parties technologies and frameworks, for example, TensorFlow, Cafe, or and many other RStudio, RServer, or even Jupyter for dealing with Python and R programming. So first of all, let me talk about deep learning at Microsoft. So actually many of our products or services are actually powered by deep learning. So here are some of our services that are powered by deep learning. So as I just said, I will talk about our content service APIs later on, and also our Skype translator. I won't be doing a demo now, but basically you can now do real-time translation between two parties using when they're doing a Skype conference call, right? And also Bing is powered by deep learning as well in terms of the searching capability and also finding similar images, etc. So these are all leveraged by a lot of our image processing techniques from Microsoft. And of course, our HoloLens, our mixed reality eyeglasses. And also we have a lot of ongoing research. In particular, we invested a lot on image processing in recent years. And later on, I will show you a real case, a partner who is focusing on image processing to do some sort of diagnosis of diabetes. So one thing that you can visit our website to know more about deep learning is to go to our content service website, microsoft.com/cognitives. So later on, I will show you a few of some of the most interesting APIs or some of the popular ones to give you an idea of what they are. So basically, we divided them into 5 categories. So we have vision, speech, language, knowledge, and search, etc. And then we have been, of course, they are all powered by big data, right? And this is from the Bing search engine. So we get a lot of data from all around the world and to build our own training model, and also with our own neural processing, neural network algorithms to do the deep learning processing. So later on, I will be showcasing you some of these APIs. And also maybe you have tried out some of our previous applications that do some sort of computer vision to guess your age, etc. Yes, many of you have tried these games and applications out already, right? So as I said before, we focus a lot on, in terms of image processing field, particular. So as you can see in this graph, well, what we call the error rate of like mapping similar images, we have like the lowest one in terms of the Microsoft 2015 ResNet survey. So this is from the ImageNet company, because they are basically we are being first place in 2015. And I'm going to show you a quick video of partner in China. Basically, they are leveraging our image processing technologies to do diagnosis based on the retina screening of the patients.
There are 100 million people with diabetes. Diabetic retinopathy, or DR, is one of the most common complications of diabetes. Patients will go blind without further treatment.
Adult DR is very easy to use. Just upload the photos and it will give the diagnosis.
We leverage our deep learning technology with a set of open source tools like Linux, Python. Training deep learning models in Azure is very easy.
With support of distributed training feature in cognitive toolkits, we can shorten the training time so we can iterate our algorithm quickly.
Azure provides N24 server, which is GPU server we use a lot. Azure commercial availability ensures our data security as well as our mission critical service level to our customers. Every day is a great day because we are saving people's life.
So AdDoc is actually leveraging our CNTK framework to build their own deep learning model. So as you may know, building a deep learning model or running a deep learning project requires a lot of time and also the computation power as well. So actually, with our data science VM, we are now equipped with, we partner with NVIDIA to have, equipped with the most powerful GPU to, basically save the time of processing lots of neural nodes and those very, large scale of processing elements in your neural network project. So later on, I will show you how you basically later on I will give you the walkthrough of how you can create a VM, a data science VM if you have time. Yeah. So basically, this slide briefly talk about what CNTK is. It is our own deep learning toolkit. So originally it's called Computational Network Toolkit. Now it's called the Microsoft Cognitive Toolkit. So over 80% of our internal deep learning workloads now runs on CNTK, and you can create a Linux-based or Windows-based VM to run our CNTK to do all sort of deep learning projects, and we have Docker support as well. And of course, when you're dealing with like data science projects, most of the time you have to write in Python and R. So we have well-supported documentation and also tools to help you with like implementing this kind of code. So and also C# and C++ and Java as well. So based on a test run by Hong Kong Baptist University, so it shows that in terms of when we compare different open source frameworks in the market, for example, TensorFlow, Caffe, or MSNet, we are now we have we achieved the shortest processing time. So basically these are the 4 benchmarks that they are using to calculate the processing speed. So we are now at basically the shortest processing times in terms of dealing with deep learning projects. So and it's production ready, so it's very efficient, and we leverage the NVIDIA multi-core GPU to run all sort of projects that we want to do. So this basically shows you the processing power with different number of GPUs. So for example, as you can see on the graphs here, the blue bar shows the 1 GPU, the processing power, so the number of samples per seconds. So if we look at when we have 4 GPUs and running on, so if the architecture is 2 times 4 GPUs, we can achieve up to 70,000 samples per second. Yeah, as I just mentioned, we now partner with NVIDIA to build our own data science virtual machine, which is equipped with our fast, very superior GPU to do all the tough work, basically the very complicated deep learning projects. So basically, we have a team of researchers in Microsoft called Cray. So a Swiss supercomputing center. So they have been working on projects to speed up the deep learning algorithms in supercomputers. So this is an ongoing project that we want to shorten the time of processing neural network-based projects. So what are the latest updates in terms of our CNTK? So originally we have CNTK 1.0, right? So now we have the 2.0. So basically we introduced the Python API. So that allows you to do all the coding in just simple Python language to basically later on I will show you a complete workflow of how you can leverage this Python API to do the first part of your deep learning projects, basically gathering all the data and then massage it and crunch it and then basically make it compatible with our CNTK framework. So we have this very easy to use Python API that allows you to do so. And of course, it's Linux or Windows, either in Linux or Windows-based as well. So that here are some of the other advantages in terms of CNTK. So apart from Python and C++ API, so it's mostly implemented in C++, so low-level and high-level Python API, and the extensibility. So the user functions and learners are in pure Python. So we have distributed readers and very efficient in, we have some very efficient built-in data readers for you to ingest your data. So later on, I will give you a little bit of deep dive of what deep learning is and also how we leverage neural networks to be the building blocks and to build complex computational networks, so supporting the application. So as I said before, CNTK is production ready. As I always mention about the image processing part of the CNTK, because this is our main focus in terms of this the development work of this framework, and also in terms of machine learning, we focus a lot of reinforcement learning as well. So maybe some of you might have heard of these sort of terms, but then later on I'll give you a brief introduction to these technologies as well. So here shows an OCR application, so basically translating all the handwritten pictures into machine-readable text. So most of the time we will use a Python data frame to store it in a matrix. For example, this is a 3x4 matrix, as you can see on the screen. So within CNTK, this what we call the data set will gone through a series of data processing procedures. So we have something called the MLP, so the multi-layer perception, which is a very crucial step in terms of neural network processing. So you can see on the screen there are a lot of nodes, right? And there are 3 layers of the neural network architecture. So these nodes are well connected to each other, and each layer is worth of different weights. And as you can see, different colors is equivalent to basically which digit you are talking about. have something called the loss function, basically comparing the estimated results with the true results. When we do a machine learning project, usually when we talk about like translating handwritten digits to machine readable digits, so we will need to make use of the loss function to see whether the engine can make a good estimation or not. So in terms of CNTK, we often talk about functions. Basically, we author those networks as functions. So we have two main functions here. So we have the model function that defines the model structure and also do the parameter initialization. And this model function, they hold parameters that will be learned by training. And the other function is called the criterion function. So that defines the training and evaluation criteria. So whether your model is accurate or not on top of the model function. And also it provides the gradients with respect to the training criteria. So all of these, you have to define it before you actually run your deep learning model. So the key differentiator of our CNTK model is that they are pure functions. So with what we call special power. So they can compute a gradient with respect to any of its nodes. And also the external deity can update the model parameters. So as I talk about, in terms of CNTK, we often talk about functions, right? So the user specifies the network as function objects. So the formula as a Python function, either on like a low level, like for example, LSTM, and also for function composition of smaller subnetworks, we have layering, and some higher order functions, so equivalent of a scan or fold and unfold. So here is the website. So because our CNTK 2.0 is quite new, so we are still, so our researchers in the US is still writing up a lot of documentation for it. But in terms of the Python API, we have very comprehensive documentation actually. So feel free to visit this website if you are interested in this API to build a complete workflow of your deep learning model. So the workflow of CNTK, in general, we'll go through these three steps. So basically, what we call the corpus, so the data set will enter what we call our own reader, and then it will pass through our CNTK network to do the GPU or CPU execution. So basically doing the packing and padding. And finally, we will train up your model. So the algorithm that we'll be using is the stochastic gradient descent, and to do some mini batching, and then you will form your deep learning model. So this is a code snippet of basically doing these three easy steps. So at the top of this code snippet, we have the reader that create the path, and then we're calling the model function to do all the GPU and CPU processing, and then the trainer to do the evaluation. So one point that is worth mentioning is that on GitHub we have some templates for some standard projects. For example, if you want to do an OCR project, or if you want to map image with other similar images that you have, well, you can actually, we have some off-the-shelf templates that allows you to make small adjustment, and then you can basically train up your model with your own data set. So the workflow will be, first of all, of course, you need to prepare the data. You need to do all the data crunching, and then in Python, and then pass through the reader, and then network, and then the learner. So so some of the unique features in comparison with other open source or some third parties deep learning framework. So as I mentioned, we have some as I mentioned before, because the model is based on functions, right? So scheduling is very important. So the most important thing is dynamic scheduling. So we don't want to have redundant tasks, redundant testing, or we want to make full use of the resources, right? So so batching and mini batching is also very important to make sure that you are making full use of the GPU or CPU. So this shows you like a symbolic loops of sequential data. So how we make it more efficient, but I'm not going to be in detail to discuss on this. And then batch scheduling, so making sure that all the tasks are processed in the most efficient way. So we have some pattern to fill in those gaps in between the tasks. So this is like a Gantt chart that to do all the scheduling, so to speed up the GPU processing. And in terms of training, we are doing data parallel training. So we're using 1-bit stochastic gradient descent to do the training for you. So basically, we quantize gradients to 1 bit per value. So this graph shows the some benchmark result of parallel training with the CNTK. So basically, I talk about the data science VM that we have on Azure, right? So not only CNTK is available in these data science VM, some other open source frameworks, the most popular ones, for example, the Cafe or TensorFlow, are also available within this data science VM. So most of the projects on GitHub on GitHub may be on other open source framework, right? So maybe on Cafe or TensorFlow. So not on our CNTK framework yet, but feel free to try out this project using those data science virtual machine because they are all compatible. So it's all pre-installed and pre-configured within the virtual machine. So you don't need to do any downloading work or any configuration work before you can actually train the data. So this is the GitHub link where you can access to our quantitative toolkit. So so basically they will show you a step-by-step walkthrough of how you can configure or implement a deep learning project. And also Stack Overflow, we have a dedicated a thread or forum which focus in particular the CNTK. And we have some tutorials and templates that allows you to run some deep learning projects. So the most popular ones, we have some off-the-shelf templates for you to play around with. And we have the Azure notebook for basically we have a lot of projects that we have built. So on the left-hand side you can see there are some Python notebook. Feel free to access them and clone them and play around with them. So now I will briefly show you how you can create your own data science VM on Azure. So this is my Azure portal. So if you look at the left-hand side, we have the virtual machines tab, and when you click on that, just press the add button and search for the data science VM. So as you can see here, we have Windows-based VM and also Linux-based VM. And once you have chose your favorite operating system, you will have a chance to select different plans. So basically allocate, so either is it just a pure CPU powered virtual machine or with a GPU powered virtual machine. So you will have the chance to do all the configurations in the next step. So I'll quickly show you what will happen when I click the VM for Linux, the Ubuntu operating system. So on the right hand side, it shows you what are the components that are already pre-installed in this VM. So for example, you have you can have access to the R server immediately, and also Anaconda package, and also our Azure command line interface. And in terms of IDEs, we have Visual Studio Code, IntelliJ, PyCharm, Atom, etc. And also we have all the frameworks, the open source frameworks that I just introduced to you in this section. So CNTK, TensorFlow, MXNet, Cafe, etc. So they are all built in, installed, and configured. So they are all off the shelf, ready to be consumed. Yeah. So just now I talked about the cognitive service APIs, right? So if you go to microsoft.com/cognitive, so some of these APIs, well actually most of them are powered by a neural network, and in particular in the language category, we have the translator API, which is powered by a neural network to do more human-like translation of the context. And another worth mentioning cognitive service API is the custom vision API. So I guess maybe some of you may have played with the computer vision API. Basically, it will recognize what's inside the image. So it will tell you it will list out all the attributes that describe the image, and also it will detect all the faces, and also give you an estimation of the age, and also it will give you the API itself will actually do some OCR, basically translating those text in the image into machine-readable text, and even handwritten text as well. So of course, these are all powered by our neural network engine, leveraging the CNTK framework. And the custom vision service is our latest update on this computer vision API. So that allows you to upload your own image and train up the computer vision model, basically. So it will recognize, for example, whether it is a taxi or whether it is Mercedes-Benz, etc. In terms of as long as you upload the images, at least 5 for each category of products or items, and then you can actually train up this API to recognize different objects of the same category. So before I end my part, I would like to show you projects that I was working on basically leveraging the CNTK framework. So this is the GitHub repo that I'm working on. So the idea of this project is to translate, not translate, but is to turn all the handwritten or machine-generated sketches into images. So basically help the police to catch thief, right? So on the left-hand side, these are the sketches that are either machine-generated or hand-drawn, and then the on the middle, in the middle column, that's the results generated by our model built up on the CNTK framework. And the right-hand side, and the rightmost column is the true results, the real images of the sketches. So this is, and so basically what I'm showing you this GitHub link is that this is all public, so you can access to my code as well. So we are basically we want to create an environment so people will contribute all their open source code, and also in this project I'm using Cafe as well. So Cafe, Torch, not only TensorFlow, and so not only CNTK. So I'm using 3 open source deep learning frameworks to help me with this project, because I'm also using another training model built by CUHK, Chinese University, to help me with this model. So and they are all open source and available on GitHub. So so we want to basically create a very in terms of sharing of code and also the open source technologies. You can go to visit our GitHub website to have access to all these templates and code, and use your own training data to play around with this model. So that's the end of my part. I guess now we will have some Q&A sessions. Do you have any questions?
Hello, sir. Well, I've seen your model on the image recognition, right? So, does that model work on movies or animation that we can recognize someone from a live video stream as well?
Well, in terms of, if you're talking about video analytics, yeah, we have something called the video indexer. So basically, with this API, you can actually recognize individual person within the video using our face API, which is equipped within this API as well. So to do the face recognition of different persons within your video. Is that what you're talking about? Like,
Sure.
Yeah. So yeah, we have face recognition as well within a video.
So besides the face,
Yeah.
can we try to recognize something else, maybe a blue card or a chip on the table, because I'm working on the gaming industry.
Well, in terms of this video API, we won't be able to recognize like individual items within a video. But of course, you can actually have like chop it down into different frames and then do the analysis one by one. Basically, like at a certain instant in the video that you have, and then you can actually call our computer vision or the custom vision API to recognize individual items within the video. But with this video API, we won't be able to just by this API to do the image item recognition one by one.
All right. Thank you.
Thank you. Any other questions?
A few minutes ago, you showed an image with
Yeah.
some water, recognizing water and things like that. Which API was that?
Oh, that's the computer vision API.
Right. Actually, I was wondering if this API it has to be run on Azure, right? Am I correct?
Yeah, it's all on cloud, so it's
Okay.
yeah.
And one thing is, let's say, if I run a virtual machine and to run this program,
Yeah.
can I just grab an image from another place and then analyze it, or does the image also have to be on the cloud?
Yeah, well, you have to upload it to the cloud first, of course, the image, but
I can't just like upload. Sorry, I can't provide just like a URL or something like that.
no, it's not.
It
well,
doesn't work that
Yeah,
way.
it's a REST API call, so you have to upload the image to this API, and then it will return back to you.
Ah, okay, I got it. So
Yeah,
it's a REST API.
Yeah,
Okay.
yeah. So
Got it.
the APIs that I've been talking about, they are all REST APIs. Yeah.
Okay.
So off the shelf. Yeah.
Okay, got
So
it.
yeah.
So that means I have a virtual server. Sorry, I have a machine with the API running on Azure, and then I can just call this API from anywhere. Right?
Yes, that's right.
Got it. Thank you.
Probably off the back of the last
Yeah.
gentleman's question. Regarding regarding language APIs, what's
Yeah.
the extent of the actual language exposure? Like, say, for example, ancient Sanskrit or Aramaic or something like, say, the Dead Sea Scrolls. Have you got anything to comment on that level?
So are you talking about more on the NLP part? So how you can use language related ones too?
So, say I've got a
Yeah.
5,000-year-old Hindi script or 5,000-year-old Chinese script.
Yeah.
And I want to translate it, but the script's actually
Okay.
the script's not actually computer generated. It's obviously being
Yes.
changed or something.
Handwritten or
Yeah, yeah.
right.
Yeah. Is that something that's being used at the moment, or is that something you have to develop yourself by inputting a computer version and then providing an image as well? How does that work?
Well, it depends on the size that you are dealing with. So of course, with the computer vision API that I just mentioned, this is talking about just one image, like of text, of handwritten text. But if you talk about like many different data set and also you want to distinguish like in many different formats, then of course you need to build your own like neural network training model, either on CNTK or other deep learning framework. Yeah. But we have also got some very simple ones that are available using the Azure Machine Learning Studio. Yeah, so you can actually upload some data set to do some very simple neural network processing. But the result is okay, but it's limited. It really depends on the data set, the size of the data set and how complex it is. Yeah.
Thank you.
Sorry. Well, actually, I think your main competitor is the TensorFlow. But
Yeah.
TensorFlow, the power of TensorFlow is not only allow you to use their existing model, they allow you to control the detail of the algorithm, which means you can manipulate the matrix of the vector
Yeah.
very, very detailed.
Yeah.
So in that manner, it means I can not only use their own algorithm, I can, like, for the optimizer, if I don't like all the existing one, like Adam gradient design, I can use
Yeah.
Newton method, and I can write it myself, how the update rule goes, every detail step, I can write it with TensorFlow API.
Yeah.
But in your demo, I didn't see this part, so can you maybe show some Python API for us to show the CNTK can also manipulate matrix, vectors, this kind of stuff?
Well, I mean, in terms of the workflow that I just showed you, it's more on the data massage part. So to do all the data crunching before you can actually push it to the CNTK framework to allow it to work on CNTK. Yeah. So this is a must do step if you want to leverage our own framework, because it's completely different compared to what the architecture of like TensorFlow or Caffe or MXNet. So it's a completely different architecture. This is a must-do step that you want to, if you want to leverage the CNTK framework. But of course, if you want to configure your own like parameters in using Python, right, in particular, right? And then I guess the question is like, so how you can use like a Python data frame to store all your data and then do whatever you want.
Is how the optimization part. Well, in TensorFlow, you can specify existing optimizer. Like I want to use Adam, I want to use gradient design. That's
Yeah.
okay. But on the other hand, you can also write your own.
Yeah.
They allow you to write your own update rule for each iteration of training step. You can update something yourself. Well, they don't. They allow you to control every detail.
Yeah.
All use existing wrapper.
Yeah.
But in your introduction, like CNTK seems just only offer you the existing stuff. They didn't offer the user, allow the user to control the detail of the optimization of the model. Is there any?
Well, the model that we, well, I mean the algorithm or the model that we are using to power the CNTK CNTK framework is using the gradient descent, as you said, which is correct. But if you want to use other models or other algorithms, of course, as I mentioned, within the project that I work on image processing, we're actually leveraging TensorFlow as well, or using Cafe library as well. So basically, you can actually combine many different frameworks to cater your needs. So not only using the CNTK, because CNTK is on gradient descent algorithm to do the modeling. Yeah.
Okay, thank you.
So I guess apart from what you mentioned about like how you can do the optimization for the evaluation part, within the data science VM, we have a lot of tools to help you with the evaluation as well. So if I have time, I'll quickly show you the page again. As you can see here, we have, for example, in terms of gradient descent, we have the gradient boosting tools, the CG Boost, and also the Webbit for some sort of learning as well. So, basically, we have many different third-party tools for you to do optimization as well. Yeah. Are there any other questions? So I guess I will pass back to the MC. So feel free to drop me an email or engage with me personally to discuss on any deep learning projects that you guys are working on. And also, I guess, this is.
Thank you, DeLong, for your sharing. Now we'll have a 30-minute short break. Light refreshment will be served at the Civil Concourse. Before we go, here are some arrangements about how you can get your T-shirt.
So before we talk about T-shirts, let's